Now then, Chapter 10. This week we're going to explore the applications and uses of wireless computing. We'll establish the difference between wireless and mobile computing, and we'll chat a little bit about the topic of cloud computing. And for most of our individual experiences, these are almost seamless, but it's important to talk about some of the differences. As with all the topics we've touched on this course, wireless technologies encompass a vast, sophisticated, and complicated set of technologies. Our goal this course is to develop a basic understanding of what the technology is and how it's used in a business setting. Now, some high-level concepts. Networks of computing devices provide a powerful way to share all forms of information. Like the internet, business networks connect all or most of their intelligent devices so information can flow from source to destination. The connections between these devices can either be some form of wires or fiber optic cables, or they can be connected without wires through radio live electromagnetic waves that use the air as the transmission medium. It's this second way of transmitting signals that this chapter will focus on for a topic. Being required to pull some form of wire between devices significantly reduces the flexibility of where you can place devices. And remember, wired media is often more easily secured, and the quality of the media is not so easily compromised. However, with the growing speeds and utility of wireless connections, wireless technologies are the fastest growing segment of network devices. Not all wireless devices are easily mobile. Mobile devices do not always support wireless connections. The primary focus of this week's lecture is on those devices that are both mobile and wireless. It may occur to you that broadcasting data signals into free air presents some unique security analysis. Authors briefly touched on the topic in this chapter, but to gain useful information on the security space requires more time than we'll give it in this course. Now, dematerialization, very cool term. Part of the reason for the growing success of mobile wireless devices comes from the acceleration of very powerful smartphones. These devices can easily work between multiple wireless media types, i.e. Wi-Fi, Bluetooth, and cellular networks. Okay, when we're doing dematerializations, we're not quite using that version, but the term dematerialization is intended to point out the fact that as these smart devices grow in processing power, memory and high-speed radio chips that support wireless communications, they also load and support a vast array of applications. Combined with high-resolution touchscreen interfaces, these devices can service all kinds of useful applications simultaneously. And there's a reduction in material device usage. As mobile smart devices become more powerful, it's starting to make sense to replace wired desktop devices in some circumstances. The convergence of useful applications into a single mobile device provides a compelling path for future component development in computing. We can expect future data processing devices to be even more powerful than they are today. Electromagnetic signals are everywhere in the world today. Radio towers have always used wireless frequencies to carry data to our radios. Like radios, all transmitting devices need to pick predefined frequency channels which they can use to communicate. Some devices hop around on various frequencies to find the best ones for transmission based on current environmental conditions. Some pick a frequency and just transmit on that frequency regardless of the environment. When multiple devices transmit on the same frequency at the same time, we get unwanted interference on that particular channel. For example, Bluetooth wireless technologies use some frequencies that are the same as microwave ovens. Fluorescent tubes and CB radios generate electromagnetic noise that can interrupt data streams in their vicinity. Some high-frequency wireless signals cannot go through solid objects. For example, infrared, lower frequency signals can penetrate some types of walls, but not most. Additionally, Wi-Fi can go through the walls in your house, while infrared cannot. In general, we choose a particular wireless technology based on our data needs and the environmental conditions in which we want to communicate. Trade-offs in selecting wireless transmission media include distance that a signal can travel, the speed of transition, cost, and the availability of those technologies in devices which we want to connect together. If you want to use your device in a Starbucks cafe, you need Wi-Fi, since that is what they use. Wireless transmission technologies listed on this page are roughly ranked by the lowest cost, lowest transition rate at the top, and each technology has its own strengths and weaknesses that are recommended for a particular application. Now, this slide is to point out that many of our smart devices also include some form of satellite communication, which we talked about briefly before. As you can see from the table in the book we created here, there are 3 general types of satellites in service today. The most common satellite service in smartphones today is Global Positioning Service, or GPS, which most people have heard of. This service uses wireless communications from the medium-range Earth orbit satellites. As with other high-frequency wireless transmissions, connecting to these satellites require a clear line of sight path. The fundamental purpose for enabling a computing device to use a wireless transmission technology is to connect to a network. Connecting to the internet is so ubiquitous these days that it's easy to forget that we are in fact operating as a node in a larger network in this capacity. Most wireless technologies have the capacity to connect with multiple other node devices through an ad hoc and often sometimes connected to a central aggregation device called an access point. The purpose of this class will only look at those technologies common to personal computing devices. Commercial applications use more powerful technologies that support greater distances and higher throughput capabilities. As with all networking technologies, the capability of a wireless network is constantly changing to include higher data rates, longer distances, and lower costs. Short-range wireless networks have historically been optimized for a distance less than 100 feet and for low incremental costs. While infrared radios are still used, they've lost out to more versatile Bluetooth technology. Early Bluetooth versions were only capable of sending relatively low signals, maybe up 30 feet. Newer versions can now send 25 megabyte signals to 300 feet. Now, this technology was designed to have a very low cost radio transmitter that was capable of networking personal devices into a small personal area network. For example, you could have wireless keyboards, mice, pointers, and other smart devices connected to your primary computing device. As the bandwidth, carrying capacity of wireless devices increased, new technologies were invented to fill in the application gaps. Ultra-wide band radios were originally designed to transmit radar information. They allow for high bandwidth and low power requirements. For a time, this technology found value in business applications, but it's given way to more popular Wi-Fi as new versions have filled in the bandwidth gaps. The Federal Communications Commission, or FCC, regulates radio transmissions for all frequencies when the power of the transmission allows it to be transmitted outside a small area. Tools like near-field communications allows for quick transfer of data between devices very close to each other. For example, transferring files between smartphones or paying a bill with your smartphone are good applications of this technology, as their weak signal strength provides some measure of privacy against nearby snooping devices by bad players. If you have an interest in learning more about these cool technologies, feel free to use your search engine and seek them out. near-field communications, and Bluetooth seem to be getting the most traction in the short-range wireless arena. The most popular of these wireless local area networks is wireless fidelity, or as we all know it, Wi-Fi. Well, there have been other technologies that have come and gone in this space. Wi-Fi has come to dominate business applications of medium-range wireless networks. As with most successful network technology, Wi-Fi standards have been developed by the IEEE, or Institute of Electrical and Electronic Engineers. Most of the time you just see that little IEEE abbreviation on the back of your devices. These kinds of professional organizations produce design specifications, and these allow everybody to create tools that can interoperate across industries. Imagine the problems you would have in connecting our appliances to our house power if every company that produces electrical outlets for your home designed them differently. Having such standards promote acceptance, which allows a particular technology design to dominate an industry. Some of you may remember a few years ago where we had literally hundreds of ways to plug in your cell phone for different charging elements. And thanks to places like the IEEE, we now have a relatively, comparatively so, small number of charging devices for both smartphones and PCs. There are many variations of Wi-Fi. As you can see by clicking the IEEE website sometime, each has a cost and performance trade-off, as we've seen before. The most common form of Wi-Fi found in business and in retail stores has a range of about 300 feet. Data rates vary depending on the versions being used and the obstacles in the path of the signal. While most Wi-Fi devices can be set to work in the direct mode, most common arrangements in business settings is to use a central transmitter with an antenna which aggregates compatible signals within its range. The general name for these devices is, again, an access point. It's sometimes desirable to enable peer-to-peer communications between pairs or closed groups of devices. These ad hoc networks can be established without a central processing point using a Wi-Fi direct technology built into the transmitter itself. Single access point installations are commonly referred to as, you've heard it before, hotspots. Newer smartphones often can run a hotspot application that makes them a portable access point that is connected to the world through a cell phone network. Your phone itself can be a hotspot. It's common for large businesses to gang access points together within the place of business to provide an interconnected network that works like a cell network for phones. As you move around within your building, your connection is handed off to the stronger access point signal wherever you are. You can check out various versions of Wi-Fi listed in the text to get an idea of how this technology has evolved over time. Wi-Fi has gained wide acceptance because of its low initial cost, easy deployment, simple support, and the access it provides to the internet. Manufacturers are compelled to provide some form of wireless connectivity to any network connected devices these days. Few would disagree that the wireless connectivity is increasingly required in commercial available network appliances. Businesses are rapidly adopting some form of wireless access with their buildings and retail outlets, and are finding that patrons are demanding Wi-Fi access while on their premises. However, there are some major hurdles in developing commercially available public Wi-Fi networks. When we go to a Starbucks or a motel, we expect that there's a wireless technology available for us to connect to the internet. To protect these services from bad guys, we are provided with a login for each different location. Currently, we can't just roam around and automatically connect to any wireless service in range, although a lot of smart devices are starting to allow this based on user preferences. At this time, most users cannot just roam from hotspot to hotspot if the hotspots use different Wi-Fi network services unless the device is specifically configured to do so. Unless the service is free everywhere, users often must log on to separate accounts. There is no current way for users to pay for the availability of connectivity to every hotspot around. Of course, one of the problems here is that most commercial sites need to secure their networks from any abuse potential. Because Wi-Fi uses radio waves available to anyone who's within range, they are very vulnerable to all manner of evil activities. The third problem, which is getting ubiquitous access to commercial Wi-Fi, is that users are not used to paying for hotspots. Setting up publicly commercial accessible Wi-Fi access will be relatively expensive, and many questions about whether commercial Wi-Fi service can survive when so many free hotspots are available to other users. Years ago, the city of Beaverton put on its plate to Wi-Fi the entire city. And if you go through some traffic lights through the city of Beaverton, to this day you'll see some little white cylinders on sticks at traffic signals, which are the leftover attempts. But even with large amounts of taxpayer funding, they couldn't figure out a way to do it securely and cheaply for the general public. Now, there are a bewildering number of different wireless technologies that are used to transmit signals far outside of a local building. Some point-to-point wireless transitions can remain relatively secure as long as they are not intended to broadcast to everyone. For example, microwave towers use high-speed connections between dishes on towers. While these point-to-point technologies exist, they're very expensive and are not typically practical for public use. Wireless broadband technologies that are meant for public use can spread the cost of transmission facilities across a wide proportion of users. Examples of such wireless technologies include cell towers for cell phones or wireless broadband, sometimes referred to as WiMAX. Cell phone networks work on the premise that there are a lot of cell towers sprinkled around your area. As you move from one towards another, your service somehow seemingly switches from one tower to another. And this way, you can potentially drive across the country and never lose your cell phone access. Well, these geographically dispersed territorial networks of towers operate over the licensed spectrum and are regulated by the government, FCC again. Now, fourth generation 4G mobile technology is capable of sending signals up to 100 megabytes per second under optimal conditions, but are still starting to get not necessarily enough. And even though many users, or most, will not see those kinds of speeds in reality on their own individual devices. Now, 5G is here, but widely being implemented is going to be a continuing problem due to compatibility issues with old technologies. Up to this being going from 2 to 3 to 4G, they've largely used the same programming language, the same physical aspects that made them backwards compatible. 5G is, as much as it has much great potential, it is not backwards compatible to the 4G and previous technologies. To use 5G, you need a whole new game set of both programming and physicality. When new groundbreaking technologies emerge, it's common for multiple standards to battle it out. And in the wide area wireless space, we see some providers using long-term evolution or LTE standards, while others are lining up behind worldwide interoperability for microwave access. Again, WiMAX. Time will tell which technology dominates the landscape. The goal for each standard is similar. They're looking for ways to work towards a pervasive computing world where most everyday devices and everyday activities associated with them are interactive with the internet and will reduce the end user's need to interact with computers as a computer per se. Now, we're taking mobile computing as a separate topic because it provides some insights into how business is evolving. While mobile computing has become very popular in the personal computing area, our focus here is going to be the business setting primarily. Businesses are enthused with the benefits they drive when employees and customers have high-powered computing at their fingertips all the time. For employees, this means that they are always available and always connected. Being able to connect to anyone in your company almost instantly changes the dynamics of communication across your entire enterprise. Now, not all employees like the fact that they can be contacted anytime, but it's now the reality as an employee. Over-communicating has its downside. Smartphone activity can be tracked, and it is easy to trace the location of the phone throughout the day and time. Employees are finding it hard to separate their home life and their work since their desktop, as we used to call it, travels with them all the time. From the employer's point of view, the barriers of geography and time are increasingly being reduced by greater and greater amounts. The efficiency that comes with instant access to data and to people makes mobile computing very compelling. Even the smallest of appliances can run commercial applications concurrently with a computing device. Much higher bandwidth availability for mobile devices has meant that more data is being moved across all different parts of the internet. Greater access to data created in commercial applications also creates growing risks for different security models. Mobile employees must be less concerned with the security dangers that exist everywhere around them to make them more efficient at doing their jobs. Now, the hardware technology is increasingly cool as we use it, and using the latest gadgets is always compelling. However, the magic in mobile computing is the access to commercial software applications. Handheld devices are increasingly used for a variety of personal and commercial connections to sophisticated applications and services. Using near-field communications, our phones can now also be used as a credit card. Given the built-in GPS software, the location of the handheld can be made available to a host of location-based commercial applications. Remember our discussions about Google Maps from a couple of chapters ago. Because vendors can see where you are, they can push advertising to you consistent with your location. Consider those ethics and privacy issues we talked about before. These push technologies, as they're called, allow vendors to have real-time relationships with their customers, for good or bad. The text does a pretty good job calling out all types of location-based applications that are being, becoming the norm for mobile computing. The B2C or business to computer connections is just one way that mobile computing can bring benefits. Mobile employees can access all kinds of inter-business applications that allow them to do their work on the fly. Smartphones are increasingly replacing laptops, tablets, and other bulky computing devices because of their ease of transport, high-quality interfaces, and they include video and audio connections. High-resolution screens and the keyboard-like interfaces make these mobile devices amazingly versatile across all kinds of applications. Now, increasingly, smartphone interfaces with sensors and other application-specific knowledges allow people to communicate across a growing number of devices. With the large memory capacity, smartphones can also be used to collect data from sensors that previously required specialized equipment. The term we keep getting these days is the Internet of Things. You hear IoT. The idea here is that we're moving into a world where any object, natural or man-made, has a unique identity, i.e. its own IP address, and is able to send and receive information over a network, i.e. the internet, without human interaction. The cost of embedding microprocessors or smart sensors into just about anything has fallen rapidly. Remember our examples about microprocessors being used in car construction. Technologies like radio frequencies, identification chips, or the RFID, are costing fractions of a penny these days. Smart toys, connected refrigerators, and sensors make every aspect of a car's activity becoming commonplace. Things that were just fantasies in the old James Bond movies are now becoming realities. Barcodes are being replaced by the RFID chips on everything from a box of cereal from the store to a car part. These smarter chips allow us to track a lot more information about the product as it moves through the system. Wireless sensors are placed everywhere in our environment to report on changing conditions. Providing a unique internet protocol address for every device and person being tracked is creating an internet of things where information about everything is available just about anywhere. Excuse me. Barcodes revolutionized commerce. Grocery clerks no longer had to memorize or type in the prices of everything, could just scan the barcode, allowing the computer to retrieve that information. However, barcodes, as originally designed, only have about 12 digits of information, and they required some back-end computer to supply the rest of the interesting information about the product. Excuse me. An improvement on the barcode is the QR code. Many of you used it and scanned it from your cell phones. These allow sort of an optical reader, like a camera, in your cell phone to connect to a back-end server, which gives extended information about whatever is assigned to that QR code. These codes are in full use today, and some vendors are using them as more robust RFID chips with their built-in antenna to transmit radio signals over short distance. The smart devices allow the scanners to be further away than traditional connections, and they provide more information that can be queried about that product. Some companies are providing location services within the store and smart cards that add the cost of things you're going through with your grocery basket. At the Amazon stores, locally you might see the Amazon stores where they say pick up stuff, put in your basket, and they'll send the bill automatically to your account. Add the availability to pay for the food with your smartphone, and the need for a grocery clerk starts to diminish. Moral of the story here is that combinations of mobile computing and smart sensors is radically changing the way we shop and purchase items. Text gives you a few examples of the expansion of the Internet of Things and some interesting new ways in which business is connecting with mobile computers and users. So, to sum up, as computers are doubling in power and dropping in cost, every 18 months, according to the old Moore's law, the current trend is to untether our computing devices and turn them into multiple application computers that blur the lines between personal and work activities, for good or ill. Stronger batteries, smaller sizes, faster, cheaper wireless technologies are eliminating the geographical and time-based boundaries that previous generations have had to deal with. The current trend is to make everything and every person a source of data available across the internet. How we work and how we conduct our personal lives is changing rapidly because of the just ubiquity of mobile wireless computing. As with all technologies, there are trade-offs to be made when adopting new ways of interacting with data. All new technologies have unintended consequences, and one could make the point that all current problems are a result of previous solutions. The benefit of the new Internet of Things are potentially compelling. The dangers are loss of privacy and security, and they're real dangers. Remember our security and ethics chapters. In Western countries, no employee is immune from the need to understand and use a mobile computer. In this chapter, we look at a few ideas designed to help you be more informed about this important aspect of data communications.